Alright guys, good afternoon. These are your notes for 13.1, Understanding Piecewise Defined Functions. So a piecewise function is a function that has different rules for different parts of the domain. So an example of what a piecewise function is right here. It's f of x equals, and then you have negative 2x plus 1 when or if x is less than or equal to 2, and x plus 1 if x is greater than 2. So it's got different rules for its domain, which is domain of the x's. So today you're going to have to be able to graph them and also write the functions. So on number 1 it says graph f of x equals negative 0.5x plus 2 if x is less than 2, and 2x minus 6 if x is greater than or equal to on the coordinate grid below. So the first thing I'm actually going to do is change negative 0.5 to negative 1/2, because it's actually easier to graph a fraction than it is a decimal. The second thing we have to do, well, first really, is we need to find the endpoints. And if you'll remember, when we graph things, if it has a less than or a greater than, the circle is open. And when we have less than or equal to or greater than or equal to, the circle is closed. So this one would have an open circle, this is going to have a closed circle on the endpoints. So we're going to find endpoints. So what these, the less than and greater than statements, they're kind of like constraints on the graph. So they're going to make the graph start and stop in certain places. So to get the endpoint, you're going to substitute the value of x into the problem. So for the first one, I have negative 1/2 times 2 plus 2. Negative 1/2 times 2 is negative 1 plus 2, and negative 1 plus 2 is 1. So my endpoint is the ordered pair 2, 1. And then we have a second equation. So 2x minus 6, and the x value is 2. So I have 2 times 2 minus 6. 2 times 2 is 4, and 4 minus 6 is negative 2. So my endpoint for the second equation is 2, negative 2. So we're taking whatever the x value is, and then the y value is the answer we get out when we substitute it in. Okay, so my first endpoint is when x is less than 2, so that's going to be an open circle on 2, 1. So I'm going to go to 2, 1, and I'm going to put an open circle on that point. Okay, to graph the line, then we just use the slope to graph. It's negative 1/2. So when you do negative 1/2, you probably say, well, let's go down 1 and write 2. But the line is where x is less than 2. This is where x is greater than 2. So we actually only can have the part of the line that's from the 2 on the x-axis backwards. So we're going to have to go up 1, left 2. And repeat that. So when we graph it, the only part of the line we graph is the left half. Well, geez. Okay. Oh, sorry. The second one, the endpoint is at 2, negative 2. And that's going to be a closed dot because it's actually equal to. It's greater than or equal to. And because it's greater than 2, we're only going to use the part of the line that's to the right, because that is where the x values are greater than 2. Okay, and then the slope on this one is 2. It's positive, but I don't want to go up because I would, or no, sorry, I do want to go up because I have to go up to right 1. I don't want to go down because I cannot go past this endpoint. Okay, so that's how we graph a piecewise function. Now, to go backwards and write it, we're basically going to write the equation of both lines of the function, and then we have to define them using their endpoints. So we have 2, so it's going to be f of x equals, and then our brace. Our first line, the slope, now even though this looks like it's going down, it's actually going up. It's positive slope. So I'm going to go here, and it goes up 2, to the right 1. So my slope for this line is 2. So we have 2x, and then the y-intercept is 2, so plus 2. If, now your book doesn't use the word if, but, oh, sorry. Most books do. Most of the time when you see these, it'll have the word if. And then x, I'm graphing, it's at the 1. So it's at, the endpoint is at 1 on the x-axis, and I'm using the values that are less than or equal. So x is less than or equal to 1. Okay. The second line, I don't see a y-intercept, but we can get the slope. So that point and that point. So it goes up 2, to the right 1, so it's going to start out as 2x. Now, when you cannot see the y-intercept, what you're going to do is kind of continue your line as, like, go on with this, using the slope to continue your line. So this will go down to right 1, down to left 1, excuse me, down to left 1. And right there would be my y-intercept, so that's negative 6. So it's 2x minus 6. And then we're going to say if x is, and we're using only the values to the right, so x has to be greater than, and it's on the x-axis 2. Okay. So it's the same as writing the equation of a line that we've done in the past. You just have to add the restriction on it. Alright, we're going to do some examples now. Let me zoom out here for you. We're going to evaluate using piecewise functions, piecewise defined. Oh, that's a little tough to see maybe. There we go. So it says on page 463, it's example number 3. And it gives you this piecewise function. So f of x equals negative x if x is less than 2. 2x plus 3 if 2 is less than or equal to x is less than 4. And x squared if x is greater than or equal to 4. And it wants us to find f of negative 2, negative 0.4, 3.7, and 5. And I guess I'm going to go ahead and switch pen color. It's very hard to see. So when we do this, the first one is f of 2. You have to look at the number they want you to find, so 2, and it has to fit within one of these inequality restrictions. Let me outline this. Sorry, I didn't know that light blue would not show up that well. So I have the whole number 2, so it's going to have to go in to the first equation, f of x equals negative x, because x is, oh, I apologize, it's going to go in the second one, because x is greater than or equal to 2. Let me just apologize again, this is supposed to be negative 2. And it says that up above it. So it is going to go in the first one. So f of x, or f of negative 2, is going to go into the negative x. So it's going to be negative 2, and negative 2 is positive 2. Okay, my next one says f of negative 0.4. Okay, so negative 0.4 is going to, again, have to go into the x is less than 2 equation, which is negative x. So we have negative 0.4, which is a positive 0.4. The next value is f of 3.7. 3.7 is going to fall in between the 2 is less than or equal to x is less than 4. So we're going to use the 2x plus 3. So we have 2 times 3.7 plus 3. 2 times 3.7 is 7.4, plus 3 is 10.4. Okay, and the last one was find f of 5. So f of 5 fits into the third one because its x is greater than or equal to 4. So f of 5 equals 5 squared, which is 25. Okay. That's about it for the notes for today. Your homework for this lesson, this is lesson 13.1. It's on page 466 to 468. You're going to do numbers 2 to 17, but I need you to skip 4, 7, 11, and 12. And then you're also going to do number 20. All right. I hope you all have a great afternoon.